Hello everyone and welcome. In this video we're going to prove the following identity. Sine of x equals x times the product as k goes from 1 to infinity of 1 minus x squared over pi squared times k squared. Now this identity was first stated by Euler while he was proving the Basel problem. Okay, but there was no rigorous proof about it. Okay, so now we're going to assume the following identity. Now, this identity was proven in a video that I'm going to link in the description. So it's pi over 2x times the hyperbolic cotangent of pi x plus 1 over 2x squared equals the sum as k goes from 0 to infinity of 1 over k squared plus x squared for all x different from 0. Now, what we want to do here is subtract the term corresponding to k equals 0 from both sides, and then multiply both sides by 2x, and finally replace pi x by t. So we're going to get hyperbolic cotangent of t minus 1 over t equals the sum as k goes from 1 to infinity of 2t by pi squared k squared plus t squared for all t different from 0. Now if we integrate these from 0 to x, we get the following. Now, we're going to look at the infinite sum as the limit of a finite sum. So we simply integrate the left-hand side. So on the left-hand side, we're just going to get for an antiderivative of hyperbolic cotangent, we're going to get the logarithm of the hyperbolic sine, and then we just need to use a property of the logs. So we're going to get the difference of the log that will be turned into the log of a quotient. Then if we apply the dominated conversion theorem, we can take the limit outside of the integral. So taking the limit outside of the integral, and in order to evaluate the left-hand side at t equals 0, we simply take the limit, since we can see that we have 0 over 0 inside a logarithm. Okay, so now by taking the limit of hyperbolic sine of t over t as t tends to 0, we get exactly 1. Okay, so we get 1. So we're going to get the logarithm of 1 on the left-hand side. Now, after applying the dominated convergence theorem, the limit goes outside, and then we use the linearity. By the linearity, the final sum goes outside of the integral. Now we can integrate the right-hand side. Okay, so if we integrate the right-hand side, what we're going to get is a logarithm. Okay, so we get the logarithm. And then we simply use a property of logarithm. So the sum of logarithm is simply the logarithm of products. Okay, so we're going to get the logarithm of products. And then we use the fact that the logarithm is a continuous function, so the limit can go inside the logarithm. Okay, so taking the limit inside, that's what we get. And then we just undo the logarithm on both sides by taking the exponential. Okay, so we're going to get hyperbolic sine of x over x is equal to the limit as n goes to infinity of the product as k goes from 1 to n of 1 plus x squared over pi squared times k squared. Okay, now taking the limit, we get the infinite product. So we're going to replace x with ix. I use the fact that hyperbolic sine of ix is equal to I sine of x. Okay, and then we can simply simplify I. Okay, so cancel the I on top and bottom, and then we end up with sine of x over x equals the product as k goes from 1 to infinity of 1 minus x squared over pi squared times k squared. So now we just have to multiply everything by x. So if we multiply by x, we get exactly the desired identity. So the sine of x is equal to x times the product as k goes from 1 to infinity of 1 minus x squared over pi squared times k squared. And this is the end of the video. Please subscribe and like, and I'll see you next time. Bye.